Good morning. I warmly welcome the students and the counselors of the diploma course in value-added products from fruits and vegetables. I shall be covering a topic that is safe chemicals and microbial limits for the food. We all know that microorganisms like human beings and animals need food and energy sources for their growth and perpetuation. But when these microorganisms attack our food sources, it results in the spoilage of the food items. That can be injurious to the human health and may lead to many severe diseases and even death. So, there are ways to check the growth of microorganisms in the food products. So, we say that preservation of the food is an essential requirement for better human health. So, why and how this preservation is done, I will be focusing on this issue. So, there are two objectives for the preservation. One, it is helpful in storage of food for future use, and second, it prevents the entry and growth of the spoilage microorganism. In this context, I will like to highlight the fact that fresh fruits and vegetables, they can be eaten only for a very short period of time, but if the same food articles are preserved with the help of certain additives, then their shelf life is improved and can be used over a long period of time. That is why the milk powder, the pickles, the jams, and the canned food that we are supplying to our soldiers on the boundaries remain edible and is good for health. So, we say that preservation is an art, and this art has a deep root in science. Today, we are exploring those deep roots in the science. There are different techniques available for preservation. One is the physical method and second is the chemical method. The physical method includes canning, freezing, drying, gamma irradiation, ultraviolet light, and filtration. And the second method of preservation is chemical additives, which delay the growth of the microorganisms, or they may be microbial poisons, or they may alter the chemical composition of the food by lowering the pH. Chemical preservatives, we will be focusing on this topic. These are basically microbial poisons. I will like to mention here, their poisons means they may be killing the organisms or they may be inhibitory for the growth of the microorganisms. Then they delay the growth of the microorganism. It refers that they alter the metabolism of the microorganisms in such a way that it is not able to multiply and produce the toxin in the food produces. Then the third issue is they may alter the food pH. In general, if the pH of the food is low, it becomes unfavorable for the growth of the microorganisms and it remains preserved. So, there are certain guidelines which tell us whether a particular chemical is good as a preservative or not. So, these are some of the points which are to be considered for a chemical preservatives. First is that it should be generally recognized as safe, GRAS, by the Food and Drug Cosmetic Act of US. It should not conceal or the damage or the inferiority of the food product. Then it should be clearly labeled on the food item. Then it should be of a good food grade value, and it should also perform the intended function for which it is designated. And then it should conform with the food additive regulations. Generally recognized as safe by FDA is an essential terminology which one has to adhere while using any chemical additives in the food. Then it should not conceal the damage, because if the food is stale or the food has lost its flavor or color, the additive should not enhance or conceal those factors, then it should be declared on the food. Like you should always mention that so and so additive has been added to the food on the label of the food. Then it should be food grade. Food grade means it should not have any ill effect on the person who is consuming the food, and then it should also perform the intended function. Intended function means either it should kill the microorganism or it should check the growth of the microorganism without altering the taste, flavor, color of the food item. Now there are certain regulations for using a given preservative, and these regulations are that it should be safe for the consumer, considering the cumulative effect in the diet. Like if you are using a certain additive over the period of time, then it should not cause any ill effect like cancer or any other diseases. Then it should not be toxic to the human beings, but it should be toxic for the microorganism. Then it should not conceal the original status. Original status refers to the condition of the food, the freshness of the food. It should not conceal the stale food and give it a false appearance of freshness. And then it should be a food grade, and the amount added of the chemical should not exceed the one which is stipulated. So on the basis of these regulations, the chemical preservatives have been classified into certain class. This classification is mainly based on their mode of action. First is that they should be antimicrobial. The second category is that they should be antioxidants. The third category is anti-enzymatic. Fourth category is natural products which are elaborated by the fruits or vegetables or the bacterial systems. And the fourth property is that fourth category is the one which are traditionally used in the food for over a long period of time. Antioxidants, as the name indicates, refers to the compounds which are antioxidant. Anti means reverse. Oxygen combines with certain unsaturated fatty acids and attack the double bonds present in the fatty acid, resulting in the formation of aldehydes and ketones, which are responsible for the rancidity of the food which we come across in fats and the products which are having fats in them. For example, the biscuits, the nuts, the oils, the vegetable oil, when they are preserved or kept over the long period of time, they develop off flavors. That is rancidity. So use of antioxidants will check the rancidity developing in the food by its action on the free radical itself, so that the further reaction is checked and thereby preventing the auto-oxidation taking place. Then antioxidants are also good in a sense that they prevent the loss of vitamins or the damage to the amino acids, or preventing the blackening and browning of the food products. I will like to focus on the fact that they minimize the damage to the amino acid, which are the building blocks of the proteins, which is ingredient of the food product. Then the second category of preservatives are the ones which target the enzyme. We have all observed that whenever we are cutting the fruits and vegetables, their surfaces go brown. This is because a phenolase enzyme acts on the food product, resulting in the browning. But when you are putting lemon juice or vitamin C, the browning is reduced or prevented. What is happening exactly during this process is that the vitamin C of the lemon reacts with the phenolase. It alters the pH to a low value so that the phenolase activity is curtailed or checked. Then there is another category of additives which are termed as the chelating agent. Chelating agent are the compounds which bind with certain metal ions which are collectively known as cations. These metal ions are essential requirement for the enzymatic activity. So when these metal ions are bound with the chelating agent, the enzyme activity is inhibited. So these are collectively termed as anti-enzymatic preservatives. Then there are other preservatives which are elaborated by the microorganisms themselves. Because microorganisms are living systems, they also need defense to overcome the competition, the crowding that they encounter in their environments, and they synthesize certain defense responses or defense chemicals which are bacteriostatic, bactericidal, and some examples are nisin and natamycin, also bacteriocins. These are very effective in controlling other microorganisms against which it exerts an action. Some examples are nisin is very active against Clostridium botulinum and is used commercially for checking the growth of Clostridium botulinum. Clostridium botulinum is a deadly poisonous organism causing food poisoning which may lead to death of the human being. Then it is also active against Listeria enterococcus, Bacillus sporothermodurans and Clostridium species. We all recall that our grandmothers, they used salt, sugars, oils, especially the mustard oil, and certain condiments, cloves, garlic, ginger for making pickles, and those pickles used to have long shelf life. So there is a scientific basis why these were used. Actually, salts which are added to fruits and vegetables resulting in the brining of the vegetables, and similarly sugars and like sucrose, glucose, fructose are generally added to jams and juices. The basis of addition of these compounds is that they exert twofold effect. One is the physical effect and second is the chemical effect. For instance, sugar act as a physical agent. They remove the water of the microorganism, resulting in the plasmolysis or the death of the microorganism. Salt has both physical as well as chemical effect, and therefore it is very good preservative agent. During olden times, wood smoke was a very conventional method of treating the meats and meat products. The basis of such treatment was preservation and addition of flavors, because wood smoke contained a large number of volatile compounds, aldehydes, ketones, which add to the flavor of the meat product. But the limitation of using wood smoke is that it is effective only against the vegetative cells, and it is not having any impact on any adverse effect on the spores which are resistant propagules. Spices and oils are other classes of preservatives which have been used since times by our mothers, grandmothers. The basis is that the mustard oil is effective against yeast. Similarly, cinnamon, cloves, onions, garlic, ginger, nutmeg and mustard, peppercorn, they all have certain essential oils which are shown to have bacteriostatic or bactericidal effect. But I will like to mention that these are very mild agents and they cannot compete with the chemical agents which are in use these days. Now coming to the next category of preservatives, they are halogens. They are oxidative agents. Halogens are generally the chlorinated compounds or iodine compounds, and they are used as sanitary agent for cleaning the equipments of the dairy industries or washing the canes. And I hope we all recall that whenever there is a certain outbreak of waterborne diseases, the doctors advise us to use chlorine tablets. So the basis is the same. Iodine coated wrappers are also good for lengthening the fruit shelf life. And then iodine water is used for washing butter and other cheese products. Then another compound which is not a halogen but has been very successfully used is the phosphoric acid, which is used in colas. So be careful while using colas, it contains phosphoric acid. So I will summarize some of the compounds which are used as chemical food preservatives. These are sorbic acids. These sorbic acid are mycostatic agents. Mycostatic because they are effective against molds, and it is also effective against a bacillus which causes the rope formation in bakery product. This table enlists the permitted levels of the different agents in our diet, and what is the conventionally used levels, and what are the substrates on which it is very successfully used. Sorbic acid, its acceptable intake in terms of the dry weight, in terms of the weight of the body. Always the chemical agents or antimicrobial is expressed in terms of the weight of the body. So sorbic acid and the salts of the sorbic acid like sodium salt, potassium salt, calcium salts of sorbic acid are added for checking the growth of molds in bakery product, and the daily intake should not exceed 25 milligram per kg of the body weight, and these are conventionally used at a level of 0.05 to 0.2%. 0.2% is a little bit higher, but the permitted level is 0.1%, and it is effective against wide range of fruits and vegetables, pickles. The table is self-explanatory. Then another category of salts are benzoic acids and their salts, and interestingly the esters of benzoic acid are also used, and these are methyl parabene and propyl parabene. Their level should not exceed 0.1 or 0.3% per of the food produced. Now I will be talking in detail about the different chemical additives and their common usage. Sodium benzoate and benzoic acid, they are used to check the growth of certain bacteria, fungi, yeast, and they are effective in food products, beverages, dressing, salads, pie and pastry. Another class of compound are sorbates. These sorbates are basically sorbic acid or the salts of sorbic acid. The salts may be potassium sorbate or sodium sorbate or calcium sorbate, and the positive point about these sorbate is that they prevent the re-fermentation of the product, and they are effective up to a pH of 6.5, that the food can have a pH of 6.5 and it will permit the activity of the sorbate. And another positive point of sorbate is that it prevents a wide spectrum of microorganisms which are possible pathogen of the food products. Then coming to sulfur oxide, they fall in the gaseous chemical preservatives. Sulfur dioxide and their derivatives, which are known as sulfides, they are termed as universal preservatives, and they are having a wide application in food industry. I will like to mention that during ancient times, Romans and Egyptians, they used to burn sulfur compounds in the wine making factories. The purpose was that they used to sanitize their equipments and the grape must with sulfur compounds by burning the sulfur. So the scientific basis of that practice is that sulfides combine with the energy currency of the microorganism, that is ATP, and thereby prevents their metabolism. They have multiple effects on the microorganisms which results in checking its growth and multiplication. But I would like to caution that it has certain negative effects, like it should not be used in food substance which have been fortified with vitamins. We come across many food producers which are fortified with nutrients, but one should avoid the use of sulfur dioxide or sulfides for treating such products. Secondly, it can result in allergic reactions, especially in asthmatics. Another gaseous compound that is widely used is carbon dioxide. It has the property of checking the growth of the organism, which are cold-loving psychrophilic microorganisms, and it prevents the spoilage of fruits and vegetables, and it also delays the respiration and ripening of the food products. after the harvest of the produce. Next important component is nitric acids. Nitric acid are mainly used for meat and meat product. They are also harmful because they may result in the loss of certain nutrients, and they may be carcinogenic when they combine with certain amines present in the meat products. Now coming to what are the factors which affect the activity of the microorganism, why we use these preservatives. Sulfur dioxide is a universal preservative. Benzoic acid targets the bacteria, yeast, molds. Sorbic acid acts on molds and yeast but not on lactic and acetic acid bacteria. Then another important parameter is as to what is the initial microbial load of the food produced on which we are applying the preservative. If the load is high, the preservative dose has to be high, and it will not be so effective compared to when the dose is low. And if the produce is contaminated, then it results in decline of the efficiency of the chemical preservatives. Chemical composition of the food is an important parameter. The most important factor is the pH. Lower the pH value, lesser is the chance of its contamination. The food with low pH value will attract only the fungi and not the bacterial pathogens. There are certain exceptions which I will not go in detail. Then physical presentation of the size of the food is an important parameter, because smaller the pieces of the food produced, the larger is the action of the preservative, because smaller the pieces, larger is the surface area. Then there are other miscellaneous factors, the conditions under which the food is stored, temperature and time is another important factors which affect the activity of the chemical preservative. Now when the food is grown under field conditions, the infection of the microorganisms or attack of the microorganisms starts from that stage itself. The major causative agent are soil and irrigation water. Soil is a natural reservoir of microorganisms. Majority of the microorganisms are present in the soil system. So when the plants are growing, it will have exposure to the soil and the microorganism, resulting in contamination of the food product. Then other parameters are inadequately composted manure. We are focusing on organic farming, and organic farming requires the addition of organic material, compost, so that can be a causative agent for the microorganisms which are going to attack the food products. And also another point is that it may be a source of heavy metal which is going to enter the food chain. Wild and domestic animals, human handling, water for other uses, because we all know pesticides, growth hormones are very commonly used as spray to enhance the growth of the fruits and vegetables. So these are some of the causative agents which can be the possible reason of food contamination by the microorganisms. And then coming to the post-harvest stage, once the food has been harvested, it undergoes a lot of handling. It may be handled by human handling, then it comes across the harvesting equipments, transport containers, it is washed with water. We all know vegetables coming from Azadpur are washed with dirty water, resulting in contamination. Then sorting and packing, transport vehicles, the conditions in which the food is stored, the storage houses, they are also a possible source of contamination. Then if there is a contaminated food lying in the vicinity of fresh foods, then it also results in cross-contamination. Then improper handling after wholesale or retail purchase. Then some food producers require cooling, like fishes and milk products that may require hydrocooling. That can be other source of contamination of the food products. This table enlists some of the bacterial pathogens linked with the outbreak of the foodborne diseases. The most important and the most severe is the Clostridium botulinum, which results in the death of the human being. Why? Because it the spores are present in the soil, but when they come in contact with moisture, low pH and anaerobic condition, they germinate into vegetative cells, and these vegetative cells synthesize nerve toxin, which may result in paralysis and difficulty in breathing. So these are very poisonous organisms and fatal in nature. Then second is E. coli. E. coli is generally seen from water sources. It is found in human feces and contaminated water. Salmonella, Shigella, Listeria microcytogenes are some other pathogens which are responsible for the foodborne diseases. Now coming to water. Water is life, water is death. If the water is clean, it is life, and if it is contaminated, it may result in death. Generally, we are seeing newspaper cuttings where we see various news. Water contamination leads to so and so diseases or death of so and so people. What is the different sources of contamination of water? Water contamination is by bacteria, viruses, then certain heavy metals which are pronounced in areas which are receiving industrial waste, then agricultural waste like pesticides, fungicides, which are all sources of chemicals, then industrial waste which are discharged in rivers and tributaries. They are all possible sources of contamination of water. Water bodies are also contaminated by human activity, by waste disposals from the factories, leaching. Leaching means passage of certain elements like phosphorus, nitrogen from the fertilizers, pesticides into the water bodies. It gets along with the water. Then accidental chemical spills. I hope we recall the Bhopal tragedy where there was spillage of the pesticides, and then chemical spills and leakage from underground storage tank. These are some of the major causes of water contamination. Then what is happening when the water is contaminated? It may be contaminated with the living organisms like certain bacteria and fungi or viruses, or it may be contaminated with certain heavy metals. So I will focus on the microbial aspect. We all know waterborne diseases like gastroenteritis, fatal diarrhea, dysentery, hepatitis, typhoid fever are some of the common waterborne diseases, and these diseases are caused by few organisms like Escherichia coli, Salmonella, Shigella, Vibrio cholera, Yersinia pestis, Enterococcus and Campylobacteria. We all know that certain viral diseases, the most well known is the jaundice, and they are also waterborne diseases. Some of the viruses which are commonly found to affect the water quality are adenovirus, enterovirus, hepatitis A, E, Norfolk virus, rotavirus and small round virus. Interestingly, there are certain parasites like Giardia, Cryptosporidium, Entamoeba histolytica, which are also potential pathogens and they cause severe diseases. For instance, Entamoeba histolytica is the causative agent of amoebic dysentery, which may be very deadly disease. So to check all these contaminations, there are certain standards which have been proposed. The count of the microorganism like Cryptosporidium should be minimum. We should kill 99.9% of the Cryptosporidium from the water. Similarly, the parasite Lambelia should be 99.9% eliminated from the water body. So when we are checking the quality of water, we generally come across a term HPC, which refers to heterotrophic plate count. Heterotrophic plate count is the growth of microorganism in Petri plate, and we get the colonies. The number of colonies should never exceed 500 per ml. Then total coliform. This is reflection of the fecal contamination of the water, and it refers to the total hygienic quality of the water, and it should not be detected in 100 ml samples. Then E. coli is also one of the type of coliform, and it should be not present in the water systems. Turbidity is a physical parameter which is due to the suspended particles or organic matter, and the turbidity level should not be higher than 5 NTU, nephelometric turbidity unit, because when we are treating water for drinking purposes, turbidity affects the treatment process. Then viruses should also be inactivated up to the level of 99.9%. Now another source of food contamination, or the major source of food contamination, can be the canned foods. Canned food refers to the foods which are packed in airtight containers. The process of canning refers to a condition where heating the food in airtight systems so that all the microorganisms are killed. Ideally, the canning is done at 121 degrees C for 15 to 20 minutes so that all the organisms in it are killed. The food processing requires that the water should be removed from the canned products, then the freezing should be done. Pasteurization is another term, and canning means high temperature sterilization. Drying. We are all aware that our mothers and grandmothers used to dry the seasonal fruits and vegetables. The purpose is that we are removing all the water present in the fruits and vegetables, making it inhostile for the growth of the microorganism, because microorganisms also need water for their growth as the human being. So in dry products they cannot grow. So this is one of a good and simple method of preservation of food. Then freezing. We all know ice creams and other things, they remain free of contamination because they are frozen. At low temperature, only a select group of microorganisms which can withstand the low temperature is able to grow, and rest are eliminated. Pasteurization is partial repeated sterilization. Majority of the milk produces or milk packets that we see are having a label that it has been pasteurized at so and so temperature. So pasteurization is a very important and successful method of preserving the food products. Canning. Canning is the term which I have already described. It refers to heating a food produce in a tight container under high temperature. Generally the temperature recommended is 121 degrees C for 15 to 20 minutes. The time is a very important parameter for canning process. This slide gives you a brief history of canning. The purpose of showing this slide is that the canning process dates back to 18th century. So what is happening during the canning process? We are heating the food to kill all the microorganisms, and the time recommended for the canning process depends on the type of food. It depends on the acidity. As I have already mentioned, higher the acidity, lower the chances of contamination, because acidity restricts the growth of many of the organisms which have a pH optima near neutral or towards the alkaline. Acidity favors only the fungal growth and a certain category of bacterial growth. Then density. Density is another parameter. Higher the density, more is the time required for preservation. Then ability to transfer heat. Ability to transfer heat is the ability how the heat is transferred from one particle, food particle, to another particle. If it is able to transmit the energy quickly, then the time required will be less. The quality to be maintained is another parameter which is to be considered while we are going to undertake the canning process. Canning is a boon, but sometimes it also is a causative agent of diseases, because sometimes there are certain physical and chemical changes may be brought about by the microorganism or by the physical environment, which results in the spoilage of the food product. One commonly constraint is that hydrogen swells are produced when the food acid react with the metal ions. These type of canes should never be used because they are toxic. Then second threat to the cane product is microorganisms. One should never use foods which may have microorganisms in the cane product. The major category of microorganisms are the Clostridia, because in caning what is happening is there is no oxygen present, so only the anaerobic type of microorganisms will grow, and Clostridium is one of the major organisms which is present in the cane food, and it is a deadly organism in a sense that it releases a proteinaceous nerve toxin which can lead to paralysis and even death of the human beings. This slide will show some of the factors of the Clostridium botulinum growth in the food products. Like generally I like to mention that it is the homemade cane products which are having high chance of Clostridium botulinum. It is a deadly poison, and because it produces a virulent toxin. This slide which is seen at the side of the slide is a picture of the spores and cells of Clostridium. These organisms prefer an environment where the acidity is low but the moisture is there and the temperature is in the range of 4 to 49 degrees C, and the oxygen level is low because it is an anaerobic organism. So a low acid, medium temperature and low oxygen pressure of the cane products is a favorable environment for the growth of this poisonous organism. It grows in absence of oxygen, it produces a protein neurotoxin, it does not grow in the presence of oxygen or nitrate. Nitrates, because these are chemical preservative and they target the Clostridium cells. It does not produce toxin at a pH 4.7, and the toxin is effective the nerve junctions, destroying the nerve junctions. And once the toxin has gone into the human system, it results in double vision, dizziness, inability to speak or breathe and swallow. So the death of a system or human system is because of the difficulty in breath. So how to check the growth of Clostridia in the cane product is to heat it at high temperature. There are some other clues which will help us to overcome the Clostridium toxin, is that honey is a major reservoir of Clostridium spores, and when this honey is fed to newborns or a child below the age of 2 years, it may cause Clostridium toxins because the child is not having immunity or the gut flora which will prevent the germination of the spores of the Clostridia in their gut. Then it is also used, the positive point of this organism is that it is having lot of commercial usage, and it is also used to treat certain neurological disorders. And another interesting aspect of this poisonous organism is that the ducks and chickens, they very often die whenever they are eating rotten food, but the vultures, they never die because they have immunity for it. So once we come to the processed food, there are certain microbiological standards. Till now we know that microbiological standards are essential because microorganisms are the major causative agent of diseases. Microbiological guidelines includes the formulation of the design required, then it should refer that the food is safe and it is having a good quality. And while undertaking the microbiological assessment of the food, we undertake 3 basic steps. First is that we collect the food sample. The sample size should be nearly 100 grams, and one should take nearly 5 samples from a food lot. After that, the food is subjected to serial dilution and total aerobic count of the microorganisms using nutrient agar is undertaken. The temperature for doing this test is 30 degree and the incubation time is 48 hours. Once we get the colonies, we resort to the indicator organism. Indicator organism refers to the hygienic condition of the food, and indicator organisms will refers to the organisms which can be specific for a given type of disease. Once we see that the food is having indicator organism, we resort to the specific pathogen count. Specific pathogen count will give us as to how many bacteria belonging to a certain group of microorganisms are present. This figure shows how the sample is dissolved in water and we undertake serial dilution, and how we get the colonies on the agar plates, which will indicate that the food is contaminated with microorganisms or not. Based on the microbiological assessment, the food is categorized into certain categories. The class A refers that the food is satisfactory. The class B says that it is not satisfactory but it can be consumed. The class C refers that it is not satisfactory, and class D refers that it should not be used at all. It is potentially hazardous to the human health. So how do we control the microorganisms? There is a terminology HACCP which refers that hazardous analysis of critical control points. It refers that one should establish the possible hazards, identify what is the critical control point or critical concentration of the level of the microorganisms, and then how to check it by effective monitoring and evaluation. It helps in assessing the microbial quality, the processing environment, and the packaging component, because these are some of the possible sources of food contamination. So in any food industry, HACCP is an important parameter for giving it a green signal. Thank you. So I will like to conclude that whenever we are eating food, we should see that it is not having any contamination. If it is a packed food, one should see for the package labels on the food items, and even if it is a canned food, we should always be very careful, and if there is a doubt, we should not ingest even a drop of the food in our systems, because it may be a possible cause of Clostridium disease. Then we should use the preservatives at recommended dose, and the preservative should be approved by GRAS, because GRAS are safe food preservatives. The food additives should be added at the recommended dose, because excess of that will be hazardous to human health. And one should, the best way is that one should eat the fresh fruits and vegetables. But even if we are going to preserve, then the preservation should be done on a scientific basis, and one should always take care that adequate preservatives are added to the food. Thank you.